Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Soorya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here. So those who are watching this particular live, just mark your attendance here. So here we will be continuing the same practice session. I will be taking some of the questions from the chemical bonding chapter again here. Yesterday in the last class we have already discussed some of the questions from the chemical bonding chapter. Again we will be completing the complete chemical bonding chapter through some practice questions over here. So in the chemical bonding chapter, we have already studied the introduction part of the chemical bonding, right? What do you mean by chemical bonding, how the chemical bonds are forming. Then we have studied about the classification of chemical bonds into ionic bonds and the covalent bonds. The ionic bonds is formed by the transfer of electrons and covalent bond is formed by the sharing of electrons. Then we have seen two different compounds, ionic compounds as well as the covalent compounds. We have seen the different properties of the ionic compounds as well as the covalent compounds. Then after that we have already studied the valence bond theory, right? Valence bond theory, this is a theory very important in the case of chemical bonding. Then we have studied the bond parameters like bond length, bond order, bond enthalpy, how they are related each other, right? Hi Asiya, good evening. Okay, we have already seen the bond parameters, how bond parameters are connected each other, right? Yes, I am going good. In the last topic we have already studied about the hybridization part. So based on those topics we are trying to cover the questions from the chemical bonding chapter. So let's move to our first question. Okay, read the question carefully. Which of the following is not an example of an ionic compound? Read the question carefully. We have already seen how ionic compounds are formed. They are formed by the ionic bond formation, right? So there will be particular metals or non-metals will be present over there. One of the ion will be forming, one of them will be losing electrons, and another one will be gaining electrons to form cations and anions. So from the given options, we need to identify which one is not an example of ionic compound. Asiya, are you sure? Okay, what is the formula of sodium oxide? Our question is which one is not forming the ionic compound, right? So as we already know, whenever we are considering the ionic bond formation, it will be formed in between metal and the non-metal. Most common example we have discussed in terms of NaCl, right? NaCl, which means sodium chloride. Sodium is the metal which will lose one electron to form the Na plus ion, and chlorine will be gaining one electron to form the Cl minus ion. Then it is combining together to form the NaCl, which means sodium is the metal over here, chlorine is a non-metal over here. So if you are comparing here, sodium chloride is one of the example for the ionic compound, right? Then calcium chloride, CaCl2 again, Ca2 plus 2 Cl minus, right? What about the case of carbon tetrachloride? Asiya, there is a correction in the chemical formula of sodium oxide. So as we already know how to write down the chemical formula of the compound, right? First we need to identify the cation over there. So sodium is the cation and oxide is the anion. So what is the valency of the sodium? As we already know, sodium is the alkali metal. So valency will be +1. And for the oxygen, it will be -2, right? So we need to crisscross the valencies. So you will get the correct chemical formula of the compound as NO2O. This is not, the chemical formula of sodium oxide is NO2O, not NaO. Is that clear? Okay. So when you are drawing the structure of the CCl4 means this is a carbon tetrachloride. You can see that out of, valency of the carbon is 4. The 4 electrons in the chlorine is formed by the sharing of electrons. So this will be an example of covalent compound. Is there any doubt? Hi Anushka, good evening. So try to draw the Lewis structure of the CCl4, then you will get a proper idea about how they are forming the covalent compound. Is that clear? Can we move to the next question? Here is our next question. Question is based on the properties of ionic compound. Ionic compounds in the solid state do not conduct electricity. Which of the following is the correct reason for it? Read the question carefully. While discussing about the properties of ionic compounds, we have already seen ionic compounds do not conduct electricity in their solid state, but they will conduct electricity in their molten state or the aqueous solution. What will be the reason behind that? Read the options carefully. Okay, I hope you will get the answer as option A over here. The movement of ions in the solid is not possible due to their rigid structure, right? Whenever you are discussing about the structure of the ionic compounds, it will be a strong crystal lattice or the rigid structure over there. So in the case of solid state, they will not be containing any free ions. The movement of ions will be restricted in the case of solid state, but if they are in the aqueous solution or in the molten state, there will be the free movement of ions happening. So they will be conducting electricity in their solid, melt state or the molten state or the aqueous solution. I hope you understand. This is the main property of the ionic compound about the conducting electricity. Okay, here is our next question. The question is based on the bond parameters. We have already seen the bond parameters like bond order, bond enthalpy, bond energy, and the bond length. So which of the following statement is about bond length is correct? Read the options one by one. Bond length is the distance between the nuclei of the two bonded atoms. Bond length increases with increasing bond strength. Bond length is independent of the types of atoms involved in the bond, and bond length is measured in units of energy. Which of the following statements about bond length is correct? So option A is the appropriate correct answer here. This is the distance between the nuclei of two bonded atoms. So if there are any two atoms are present like A or B, the distance between the nuclei of two atoms will be the bond length we have already measured here. So option A is the correct answer here. Now we are moving to the next question. Which of the following is true regarding the bond order and bond length? How bond order and bond length is related to each other? Again, option A is the correct answer here. So bond order, as we already know, is the number of bonds formed between two atoms in a compound. So for example, if you are taking the fluorine molecule, F2 molecule, as we already know, it will be formed by the single bond formation between the two fluorine atoms. So bond order is equal to 1 over here. Then if you are asking about the case of oxygen molecule, as we already know, there will be a single double bond present between two oxygen atoms. So bond order is again equal to 2 here. Then if you are asking about the case of nitrogen molecule, N2 molecule, as we already know, in the case of nitrogen molecule, there will be triple bond present in between two nitrogen atoms. So bond order is again equal to 3 over here. So this is the increase in bond order. So whenever we are discussing about the bond order and the bond length, as we already know, okay. So whenever we are discussing about the case of bond order and bond length are inversely proportional, right? As the bond order increases, bond length decreases. So if you are comparing these three molecules, as you already know, bond order increases from fluorine to oxygen to nitrogen, right? So their bond length will be decreases from fluorine to oxygen to nitrogen. I hope you understand. So you can expect these questions in terms of bond order and bond length in the case of bond parameters. Okay, now we are moving to the next question. Three statements are given here. Again, the question is based on the bond parameters. You want to identify whether the three statements are correct or wrong, correct or incorrect. Okay, what will be the answer? Read the statements one by one. First statement is given, the bond angle is expressed in degrees. So this is again true statement, right? As we already know, bond angle is always expressed in terms of degrees. Then the bond dissociation energy or bond energy is expressed in kilojoule per mole. That is also again true statement. When we are discussing about the bond enthalpy, we have already seen the unit of bond enthalpy or the bond dissociation energy will be equal in terms of the kilojoule per mole. Then the bond length is measured by spectroscopy, X-ray diffraction or electron diffraction techniques. That is again true, right? Which means that all the three statements A, B and C are correct. So option A will be the correct answer here. I hope you understand. Now we are moving to the next question. So the next question is based on the bond angle of different molecules. What is the bond angle of HNH in ammonia molecule? So while discussing about the hybridization part, we have discussed about the exceptional case in the case of sp3 hybridization. One of the example is the ammonia molecule, right? So we have already seen the structure of ammonia molecule along with their bond pairs and lone pairs. So while discussing at that time, I have already mentioned the bond angle is already there. So what will be the bond angle of ammonia molecule, especially in the case of HNH? So this is the shape of ammonia molecule, right? What is the hybridization over here? What will be the hybridization of ammonia molecule? Yes, option C is the correct answer, 107 degree. So what is the hybridization of ammonia molecule? Anyone? So we have already studied the steric number concept, right? Steric number, how to find out the steric number? That is equal to the sum of sigma bonds plus number of lone pairs. So here the total number of sigma bonds is equal to 1, 2, 3. So 3 plus 1 is a lone pair. So 3 plus 1 is equal to 4. If you are getting the steric number is equal to 4, you can identify that the hybridization will be sp3 hybridization. Now in general, for the sp3 hybridized molecule, we will be expecting the shape of the molecule will be tetrahedral with a bond angle of 109.5 degree. But here in the case of, this is the exceptional case, this is the case of what? Water and ammonia molecule. Because of the presence of lone pairs, the bond angle will be reduced to 107 from the tetrahedral bond angle in the case of ammonia molecule. I hope you understand what is the difference between sp3 hybridization in the case of normal tetrahedral molecule and the ammonia molecule. Is that clear? Here is the next question. Okay, fine. Again, three statements are given here. Bond energy of CH3H is for 26.8 kilojoule per mole, and statement B, bond energy of O double bond O is for 97.9 kilojoule per mole, and the bond energy of ClCl is 242.7 kilojoule per mole. We want to identify whether these three statements are correct or incorrect. Again, option A is the correct answer, which means all the statements are correct over here. According to this question, we have an idea about that. The bond order is directly proportional to the bond strength or bond energy. So while comparing the bond order over here, you can say that in the case of oxygen molecule, right, it will be having the maximum bond order given here because it is bond order is equal to 2, which means 2 bonds are formed in between 2 oxygen atoms. So this will be having the maximum value of bond energy over here. So this is a true statement. Then if you are comparing the CH3, H and ClCl, you can identify that there will be a proper table given in the PPT while I was sharing about the bond parameters. While comparing the values, you can see that in the case of methane molecule, the bond energy is equal to 426.8 kilojoule per mole. That is again true. Then what about the case of chlorine molecule? Again 242.7 kilojoule per mole is the bond energy. So this is again true, which means all the given statements are correct. I hope you understand. Now we are moving to the next question. Okay, read the question carefully. Assertion reason type question. Assertion is given, bond order is a measure of the number of chemical bonds between two atoms. The reason is given here, a higher bond order indicates stronger bonding between two atoms. So indirectly they are asking how bond strength is how bond strength is related to the bond order. We want to identify whether the assertion and reason are true or false and if it is the correct explanation or not. So while discussing about the bond order, I have already mentioned it is the measure of the number of chemical bonds formed between two atoms in a molecule. Especially in the case of diatomic molecule, it will be the number of bonds between two atoms. So obviously assertion is a true, right? Then what about the case of reason? A higher bond order indicates that stronger bonding between the two atoms, which means that bond order is directly proportional to the bond strength. So which means that again option A is the correct answer. Both A and R is correct and R is the correct explanation of A. Okay. Now we are moving to the next question. Some of the molecules are given here. Among the following, the molecule with bond order is equal to 1. So try to draw the structure of these molecules, H2, O2, N2 and He2 molecule. Which of the molecule will be having bond order is equal to V1, which means that in the case of these two atoms, they will be having bond is equal to, number of bond is equal to 1. What will be the answer? Options are already given here. Hydrogen molecule, oxygen molecule, nitrogen molecule and helium molecule. Okay, is there anyone got the answer as option A? And is hydrogen molecule, right? When you are drawing the structure of the hydrogen molecule, these hydrogen atoms are forming a single bond in between the H2 molecules. So bond order is equal to 1 over here. Then what about the case of oxygen? O double bond O, right? So bond order is equal to 2 over here. Then the case of nitrogen molecule, N triple bond N, that is bond order is equal to 3 over here. Then while discussing about, if you are going to the higher class, about the grade 11, you will be getting an idea about the molecular orbital theory in the chemical bonding and molecular structure in the grade 11 syllabus. Then you will get a proper idea why He2 molecule is not exist. It is generally does not exist because of their bond order is equal to 0. So according to our question, option A will be the correct answer. And here one point you have to keep in mind that in the case of He2 molecule does not exist because of their bond order is equal to 0. You will get to know when you are discussing about the molecular orbital theory in the grade 11 chemical bonding chapter. Here is the next question again. What is the bond angle in the case of water molecule? This is again the another exceptional case for the sp3 hybridization. What is the bond angle of HOH bond in the water molecule? So option C is the correct answer, 104.5. So if you are drawing the structure of water molecule, as we already know, H2O, right? 2 hydrogen atoms and 1 oxygen. In the case of oxygen, there will be 2 lone pairs are present. So this will be the bond angle that is equal to 104.5 degree. Again, if you are comparing the steric number over here, number of sigma bonds is equal to 2 here and number of lone pairs is equal to 2 here. So again 2 plus 2 that is equal to 4 will be the steric number. So the hybridization is sp3 hybridization. So we will be expecting the shape will be tetrahedral, but because of the presence of these 2 lone pairs, the shape will be reduced to bend shape or V shape with a bond angle of 104 degree. Is that clear? Okay, here is our next question. A table is already given here. We just want to match the set 1 with the set 2. In the set 1 they are given the covalent compounds, polar covalent compound and non-polar covalent bond. And in the set 3 they have given the examples of the molecule. So how we can match the column? Hi Vidya. So while discussing about the covalent bonds, we have again discussed about the classification of covalent bond into polar covalent bond and the non-polar covalent bond, right? So if they are polar covalent bond, there will be the electronegativity difference between the different elements. But in the case of non-polar covalent bond, they will be formed between the same type of elements. So option A will be the correct answer here, which means that covalent compounds, as we already know, they are non-polar in nature, so they will be soluble in benzene because like dissolves like, right? Polar compounds will be dissolved in polar solvents and non-polar compounds will be dissolved in the non-polar solvent. So here covalent compounds are soluble in benzene because it is a non-polar solvent. Then what about the case of polar covalent bond? Polar covalent bond means they are formed by the sharing of electrons between two elements or atoms which will be having the difference in their electronegativity. So if you are taking here in the case of HCl molecule, as we already know, in the case of HCl molecule, there will be electronegativity difference between the hydrogen and chlorine. Chlorine will be more electronegative. So there will be the maximum ability of chlorine to attract the shared pair of electrons towards itself. So it will be forming a delta negative charge over here, and hydrogen will be forming a delta positive charge over here. So there will be existing a polarity over here, or this compound is known as a polar covalent bond. So the main point you have to keep in mind that whenever you are discussing about the polar covalent bonds, they should be having, in the combining item, they should be having the difference in their electronegativity. Then the last one, non-polar covalent bond, which means they are formed by the same type of elements of the atom. So in the case of hydrogen, there is no any electronegativity difference over there, right? So there will not be any partial positive charge or partial negative charge happening over there. So they are known as the non-polar covalent compounds. So according to these options, option A will be the correct answer here. I hope you understand. Here is the next question. In which of the following molecules is the bond angle closest to 109.5 degree? Read the options carefully. One is ammonia, water, CH4 and carbon dioxide. Which one of the molecule will be having the bond angle of 109.5 degree? In the case of NH3, we have already seen it is 107 degree, right? Because of the presence of lone pair, the bond angle will be reduced to 107 degree because of the shape of pyramidal shape. In the case of water molecule, we have already seen 104.5 degree because of the presence of two lone pairs. And what about the case of CH4 molecule? CH4 molecule, if you are drawing the structure of CH4 molecule, as we already know, it will be having the steric number. Steric number is equal to total number of sigma bonds plus lone pairs. Here only 4 sigma bonds are present, which means sp3 hybridization with the shape of tetrahedral because there is no any presence of lone pairs. So obviously their actual as well as the expected shape will be tetrahedral with a bond angle of 109.5 degree. Clear? So option C will be the correct answer here. And what about the case of carbon dioxide molecule? So this will be the shape of carbon dioxide molecule. If you are taking the steric number over here, out of a double bond, there will be one single bond and one pi bond. So if you are comparing these two double bonds, there will be 2 sigma bonds are present. So steric number is equal to 2. If the steric number is equal to 2, hybridization will be sp hybridization and shape will be linear. Shape will be linear with a bond angle of 180 degree. Here is the next question. According to the postulates of valence bond theory, a covalent bond is formed by which process? Option C is the correct answer. So the main point or the main postulate of the valence bond theory is the atomic orbital overlapping. So they will be forming sigma bonds as well as the pi bond. Sigma bond is formed by the head-to-head overlapping or the axial overlapping, and the pi bond is formed by the sideways overlapping or the lateral overlapping. So the main point or the postulates of the valence bond theory for the formation of covalent bond is the overlapping of atomic orbitals of two atoms to form sigma bond as well as the pi bonds. Here is the next question. The question is based on the shape of s orbital. Okay, I hope I'm audible, right? There is some construction work going on over here. That's the background noise is coming. Okay, what is the shape of s orbital? This is a very easy question, right? While discussing about the overlapping of atomic orbital, we have already seen the shape of s orbital. So shape of s orbital is dumbbell, and in the case of p orbital, it will be, sorry, shape of s orbital is spherical, but in the case of p orbital, it will be dumbbell shape, right? So this is a very easy question. Option B will be the correct answer. That is spherical shape for the s orbital. So they will be easily forming the overlapping or head-on overlapping or the axial overlapping to form the corresponding sigma bonds. Here is the next question. Sigma bond is formed by which type of overlapping? Whether it is formed by the head-on overlapping or sidewise overlapping or the end-to-end overlapping. So there will be different names for the head-on overlapping. So what will be the answer for this question? It will be end-to-end overlapping, right? So while we are discussing about the overlapping of atomic orbitals, we have already seen. Let's take an example of PP overlapping, right? So this will be one of the p orbital and this will be the another p orbital. If they are forming head-to-head overlapping, if they are overlapping the head-to-head overlapping or head-on overlapping, it will be forming PP sigma bond. So the another name of head-on overlapping is known as the end-to-end overlapping, end-to-end overlapping or head-on overlapping or axial overlapping. So this is resulting in the case of sigma bond formation, head-on overlapping. So I hope you understand. So in the case of pi bond formation, there will be the lateral overlapping or the sidewise overlapping. Here is the next question. Which orbital is involved in the formation of H2 molecule? So in the case of hydrogen molecule, are you sure it is option C? Hydrogen molecule means two hydrogen atoms are present. So obviously in the case of hydrogen atom, there is only one orbital, that is 1s1 orbital. So if they are forming the H2 molecule, 1s1 orbital of the one hydrogen will be overlapping with the another hydrogen, another 1s1 orbital of the second hydrogen atom to form the headwise overlapping, right? Headwise or head-on overlapping on N to N overlapping, so they will be forming the H2 molecule. Single bond, S sigma bond is formed over here. So the orbital which is present in the sigma bond formation over here is the 1s orbital. So option A will be the correct answer. Here is the next question. Which of the following statement is about pi bond is incorrect? Which of the following statements about pi bond is incorrect? Read the options carefully. Formed by the lateral overlapping, less stronger than sigma bond, allows free rotation and present in multiple bonds. Here option C will be the correct answer. So as we already know, pi bond is formed by the lateral overlapping or the sidewise overlapping of atomic orbital, right? If they are overlapping through their sidewise, there will not be any chances for the free rotation of atomic orbitals. So it does not allow the free rotation. Then as we already know, if you are comparing the overlapping in between sigma bond and pi bond, in the case of sigma bond, there will be the head-to-head overlapping or, okay, head-to-head overlapping, right? Head-to-head overlapping in the case of sigma bond, right? But in the case of pi bond, there will be the sidewise overlapping happening. There is no extent of overlapping will be minimum in the case of sigma bond. So minimum in the case of pi bond, but maximum in the case of sigma bond. So the pi bond will be less stronger than the sigma bond. So all other three options are correct regarding the pi bond. Option C will be the incorrect regarding the pi bond formation over here. Here is the next question. Which of the following bonds allows free rotation of atoms around the bond axis? So option B is the correct answer here. As we already know, in the case of sigma bond formation, they are formed by the head-on overlapping. Okay, head-on overlapping is present over here. So there will be the maximum formation of the free rotation of atoms along the axis. So option B will be the correct answer here. Here is the last question. Which of the following is not a feature of hybridization? So while discussing about the case of hybridization, we have already seen in the case of hybridization, as we already discussed here, the hybrid orbitals does not form the pi bonds. Generally, unhybridized orbitals will be forming the pi bonds, right? So while discussing about the carbon and its compounds, we have already discussed how the unhybridized orbitals are forming the pi bonds. So this is the only one incorrect statement regarding the postulates of hybridization. So option B is the correct answer. Okay. One more question is there. The molecular shape of a molecule is determined by which type of bond? Whether it is formed by the sigma bond or pi bond. One second, option B is the correct answer. Sigma bond is responsible for the shape of the molecule. Then which bond is always formed first between two atoms? If you are comparing oxygen molecule over here, there will be double bond is present. The first bond formed is a sigma bond and the second bond formed is a pi bond. So here option D will be the correct answer. That is, sigma bond is formed first between two atoms in a double bonded compound or the multiple bonded compound. Here is the next question. Which molecule contains both sigma and pi bonds? We have already discussed the shape of this molecule or the bond order along with the structure of these molecules. You just want to identify which molecule contains both sigma and pi bonds. Again, oxygen molecule, O double bond O, one sigma and one pi bond. So option B will be the correct answer here. Okay, fine. So that was the last question from this practice session. So we have already completed the chemical bonding chapter. Hi Hafsa. We have already completed the chemical bonding chapter. Here we have completed some of the questions from the chemical bonding by 2 classes yesterday and today. So there is a gentle reminder about the SCORE examination. As we already know, Sri Chaitanya Academy is providing an international level scholarship examination which will be conducting on September 28 and October 12. So the link will be provided in the description for the registration. You should register before September 26 for the examination. So they will be providing exciting opportunities here, NASA trips, exciting gadgets, up to 100% scholarship is providing there. This is applicable for the students from grade 3 to 12 is applicable. There will be online as well as offline experience. Offline exams will be available. Okay. So link will be provided in the description. Just register now, those who are not registered yet. Before September 26, you need to register for the examination for the September 28. So thank you so much all of you. I hope you guys enjoyed the session. If you really like the session, hit the like button, subscribe our channel and share this particular session to your friend also. If you want to get the session PDF about the class, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF after all the classes over there. So thank you so much all of you. See you in the next class. Bye.